Thank you, Chad. And thank you to all of you for being here on this last day. I know it's been a long week, a lot of stimulating and fascinating talks, but I'm very grateful that you stuck it out and you're here bright and early today. I also just wanted to repeat the thank you to the co-organizers. Can we give the co-organizers a round of applause? It's been a really fantastic, interdisciplinary, very well-curated workshop, and I know a lot of work went into that, so thank you to the co-organizers. So today I'm going to be talking about a set of ongoing projects that we have with the San Francisco School District to help them improve diversity and equity in their schools. Okay, and I'll be a little bit more precise about what I mean by school choice and the lens that we're going to take. This is very applied work. My background is I'm in the Management Science and Engineering department at Stanford. If you haven't heard of that department, it's basically where the operations research people sit. And so I'm an operations researcher by training. And so usually I do a lot more sort of stuff in theory land, just mathematical models and solving them. So this is very applied for me, but I think that's part of what makes it very exciting, challenging and real, and also probably really interesting to many of you. And so I'm happy to take lots of questions during, especially as I'm setting up the context, introducing you to this domain. I'm sure it's new for many of you, so feel free to ask questions. I have about 45 minutes of material, so more questions at the beginning means less sort of discussion at the end, but I think that's fine. I'll be showing you a lot of what we did in like the first 30 minutes of material. Okay, so the high level background I want you to have in the back of your mind is that schools across the United States are resegregating. Okay, so what do I mean by this? So on the left, I'm showing you here a percentage of Black students in schools in sort of, this was an infographic that divided the states of the US into 5 regions. And one of the regions was states in the West. Okay. And we're looking at the percentage of Black students and in these states who attend schools that are 90 to 100% minority. Okay. And you can see that that percentage has been decreasing since segregation in schools was first ruled unconstitutional in Brown versus Board, but then has been increasing again since about the 80s. Okay. On the right, I'm showing you a different cut of data, different level of geography. I'm specifically focusing on the San Francisco Unified School District, which I'll be abbreviating throughout this talk as SFUSD for short. This is the school district that I'm working with. It covers all of the San Francisco city area. Okay, so pretty big district. And here I'm looking at a slightly different cut of the data. I'm looking at what percentage of schools have at least one racial subgroup that takes up at least 45% of the school. And so I could have 2 subgroups, right? I could have one group taking up 45%, another group taking up 45%. So there's 2. One moment. And you can see that this percentage has also been decreasing since the 50s and 60s and then increasing again since the late 80s. Yes?
A question for my information. Do you have an idea of what is the expected number of Hispanic population in those schools?
Yeah, amazing. Great question. So I'm going to show you some demographics of San Francisco in just a moment. Yeah, San Francisco, at least the public school system, is very highly Hispanic. I forget the exact percentage. I think it's like 56, something like that.
Population-wise, what's the expected number? I mean, for that generation, what's the expected number of Hispanic children?
Yeah, I'm actually not sure how much changing demographics is playing into sort of these steps. There are specific policy changes that correspond to sort of these big stepwise things that I'm happy to discuss those offline. So yeah, we could spend all day on this slide just being like, well, what's driving this? What can we explain? What sort of can we extrapolate to say about other districts, other measures? I just wanted to have this kind of in the back of our minds, illustrative, and we can talk more about it later. Okay, so one quick slide on the fact that we're seeing a lot of resegregation in schools, and just to say one more thing, this plot that I'm showing you is not unique to schools in the West. It's sort of across the US, okay, and it's not unique to this way of cutting the data. And so, well, why is this a problem? One reason that this is viewed as problematic in the education literature is that there's recent work that came out of the Stanford Educational Opportunity Project that shows that racial segregation is strongly associated with the magnitude of achievement gaps between races. Okay? And not just the magnitude, but also with the rate at which the gaps grow. Okay? And what this recent research was showing is that actually racial segregation seems to be the most harmful when it concentrates minority students in high poverty schools. Right? So when we have the confluence of both racial and socioeconomic segregation, that's when these academic gaps are most prevalent and the largest and grow the fastest. Okay, so that was basically the content of this very influential paper from about 2018. So it's just one reason we might be worried about the fact that our schools are resegregating. And I was showing you sort of, again, this combination of, well, actually in the previous slide, I was showing you just segregation by race, but we're seeing a lot of these patterns by socioeconomic status as well. Okay, and so the lens that we're going to take today to try to start to scratch the surface, start to address this issue, is something known as student assignment. And so what is student assignment? Student assignment is the policy and the process that's used to determine which students are assigned to which schools. Okay, and so if you've heard of student assignment before, you've probably heard about it in the context of something known as neighborhood assignment, which is just you go to your neighborhood school. Right? There's a school, that's kind of the closest one you go to, you live in its catchment area, and that's where you go to school. That's one example of a student assignment policy. Another type of policy that I study is known in our academic literature as school choice. Now that's a little bit different to the way school choice is used in sort of popular policy language. So how I'm going to think about school choice today is not vouchers to go to private schools. I'm going to remain within the public school system, and I'm going to be referring to something that you might know as the lottery. All right, so this is, instead of just saying you go to this one school depending on where you live, I'm going to let you express preferences over schools. I'm going to give a very particular structure in which you express preferences. You give me my your rank ordered list, your first choice school, second choice school, third choice school, so on and so forth. And I'm going to take all of those preferences, put them into an algorithm. And the algorithm tells you where you go to school. Okay, and so this whole process, how the algorithm influences how people report their preferences and how we design the map from inputs to outputs is the kind of thing I usually study. Okay. And we're going to ask, can we sort of think a little bit more broadly about student assignment policy in order to help resegregate our schools? Okay. So what I want to do today is I want to dive in to the San Francisco case, introduce you to this one particular school district and the problem that they were facing with segregation and their student assignment policy there. Next, I'm going to show you a little bit of how we might move from math to policy and some of the math questions that still remain. Excuse me. I'm going to show you the results of some of the work that we did with the district that led to their decision about a new policy for student assignment in 2020 that we're working with them to implement by the 26-27 school year. And then I've left, so this is sort of like hopefully the first 30 minutes, and I'll have maybe 15 minutes or so to ask, well, what does that mean for this workshop, right? How does that make us think about equity, mathematical foundations, questions in transportation? Okay, so thoughts, comments, questions before I tell you more about San Francisco. Okay, great. So I have here for you a map of the San Francisco School District. This is sort of the entire city of San Francisco. It's quite a large district. Each of the red dots here is an elementary school. And so the problem that we're trying to address here is we're assigning students to public elementary schools in the San Francisco School District. And for elementary students, there's about 5,000 incoming kindergarten students each year. These numbers are a bit off. It should be about 100 and something programs at 70 something schools. Not sure why I have these numbers. Okay. So this is sort of the scale of the district. It's quite a large district. And going back to the question about what is the demographic composition. Here's one snapshot in time. This is from the 2010 census. And you can see that we have quite a lot of racial segregation in where people live in the district. All right, so if I take one illustrative example, let's look at my Black population. They comprise about 6% of the school-going population in San Francisco. And you can see a lot of that 6% are concentrated here in the southeast of the district. Okay, and so San Francisco right now currently uses school choice, or the lottery system, in order to assign students to schools. And one of the reasons that choice was introduced in 2011 was, all those steps I was showing you. This was one of those steps where they were saying, we have all this segregation in our schools, both racially and socioeconomically. Maybe one of the reasons that there's segregation is that we have residential segregation. And so if we can disentangle where you go to school from where you live, maybe we can help reduce the segregation in schools, even if the neighborhoods are still segregated. Okay, so there's this hope that giving people the option to go to school anywhere in the district rather than just their neighborhood school would help disentangle neighborhood and school segregation and reduce segregation in schools. Okay, so that was the hope. I see some skeptical faces. Okay. First, let me just explain a little bit the history of segregation in San Francisco. This plot is not unique to San Francisco. Across the United States in the 30s, there was a systematic practice known as redlining, where certain geographic areas, these are often areas that were very under-resourced Black areas of cities, were denied access to wealth-building resources, such as loans, other opportunities to purchase property. And so this practice was known as redlining, and I'm showing you on the left here a map of San Francisco. The red blocks are the geographic areas that were redlined in the 30s. What I'm showing on the right is a map from 2010. This is the district collects every year free or reduced price lunch data. And so if you're eligible for free or reduced price lunch, I've colored that family in yellow, and that's a measure of socioeconomic need. Okay? And so you can see that the yellow dots kind of very strikingly, upsettingly, really match up super well to the pattern of redlining in the 30s. So these historical policies have had ongoing systematic effects on the distribution of unequal distribution of race, of wealth amongst different races, and also geographically. And we see those patterns even, 80, 90 years on. Okay. And so this is the kind of geographic segregation that we're working with. And the hope was that school choice would help make the schools less segregated than the districts. Okay. So what I'm showing you here on the right here, I'm showing you two things. First, I have a heat map. The heat map is just a different representation of the same data, right? I've taken the students who are eligible for free reduced price lunch, and each of these geographic units is just an attendance area. This is sort of drawn around each school, and I'm looking at the percentage of students living in that attendance area who are eligible for free reduced price lunch. So a heat map version of the yellow dots on the previous slide. What's new is on top of that, I've superimposed with the red dots the 50% of schools which have the highest percentage of students attending the school who are eligible for free reduced price lunch. Okay, so you can think of this as sort of the distribution of socioeconomic need where people live and also in the schools. Okay, you can see that the schools with the highest proportion of students with this socioeconomic need basically are in those areas where a lot of those students live. And it's not just because people are going to their closest school, right? There's a choice that's been used at this point for 7 years. And we see in the data that people are traveling quite far across the district. They're not just going to their neighborhood school. About 40% go to their neighborhood school, but a good 60% go all over the place. But we're still seeing this almost exact correspondence between residential segregation and school segregation. Okay, so because of this and many other issues, in 2018, the Board of Education of San Francisco resolved to redesign their student assignment policy. They wanted to make it more diverse, so the schools could be more representative of the racial and socioeconomic makeup of the district as a whole, rather than segregated locally. They wanted to improve predictability. I said before that San Francisco was using district-wide choice. So if you think about practically what that means, right? There's 150 different programs that you can apply to. Okay, that's a lot of programs to consider as you're making your rank ordered list. And about 10% of students were every year something they called designated. And so this is you're assigned to a school that was not on your list. Okay? So maybe you put in a lot of effort, you listed like 50 schools, and then somehow you ended up on like one of the 20 you didn't even list. Right? And so there is this sense of unpredictability. Like I have no idea where I could end up. There's a 1 in 10 chance you could just be like anywhere. Okay, and the third desiderata was proximity. People wanted to be able to go to school close to home. And so you can see immediate tension, right, between, say, diversity and proximity. So in particular, if we look at sort of these very popular student assignment policies, if we use neighborhood assignment, the immediate challenge is that we'll have residential segregation just reflected in the schools. But they've been using district-wide choice for a long time and not seen a lot of improvement. And when we looked at our data, we sort of see descriptive evidence of choice-driven resegregation, that people like to go to schools where the composition of the school looks a lot like their own background. Okay, and so when we started working with the district in 2019, they'd already had this resolution for a little bit, and they had a couple of concepts they wanted to explore. I'm not going to go too much into the concepts, except to say that there were 3 concepts, and there were 2 of them where they wanted to restrict choice into geographic zones. Okay, and what I mean is instead of letting you choose from the whole district, I'm going to divide the district up into pieces, geographic pieces. The piece you live in determines the schools that you get to go to. You get to go to the schools also in that piece. Okay, so I'm basically like districting, taking a big district of 150 programs, dividing it into many smaller districts. Okay, so this was the context that we entered into. Comments, questions, thoughts?
So,
Yes.
So the latter policy of districting, wouldn't that just reinforce segregation? So it's, okay, so it was just a reference.
Great question, yeah. So like, why did they think districting would help?
Yeah.
Right? And so, well, first, you can think of neighborhood schools as like the smallest possible districts, right? And so what we see is if you have really tiny districts, they're just going to reflect the residential segregation. So maybe we can make the districts big enough that they're able to capture different demographics, okay? And if they're small enough, that can help reduce unpredictability, right? But there was still this question, right? If you have district-wide choice and you still have choice-driven resegregation, like why would like smaller zones do anything to help with this? And well, they didn't have an answer. We had some thoughts, and I'll get to that in a few slides, yes.
You don't confirm that the choice-driven segregation is actually a reflection of students' preference.
So we have choice data dating back to the first year that they started using the choice system. And so what we can do is we can estimate choice models. I'll tell you about that in maybe like 5 to 10-ish slides.
Can we say then that's actually the humans actually prefer segregation? Can I interpret that way?
So with the choice modeling, what we're trying to do is we're not trying to explain choice, we're trying to predict choice. So we see that the patterns of choice, there's high correlation between your top choice schools and those for which the schools that have students that look racially and socioeconomically like you. But we're putting in a lot of features, we're not trying to say anything causal. And so, yeah, there's correlation, don't know if it's causal.
You had in the beginning something that related diversity to an actual measurable correlation in terms of widening gap and so on, which
yes.
I personally found very important
yes.
because it really gave like a real fundamental sort of reason to do it. What about proximity? Is there something like that as well, right? Because one would think that if you waste more time of the day, right, sitting on buses, that could also be detrimental to child development and things like that. Is there something fundamentally understood there?
Great point. So I am not an expert in education literature, but we've heard a little bit during this workshop already about the effects of, getting to school on time, how long you're spending on your commute, on how well you're able to, how likely you are to even go to school, first of all.
Yeah, the reason I'm wondering is that it was clear that it's a nuisance, right? It's very annoying and so on.
Yes.
But I'm really wondering how bad it actually is, because also you could argue there's team building exercises, conflict resolution training of being with kids on the bus, and sometimes there's infighting, and so maybe other than the nuisance it's actually not that detrimental, or maybe it's really bad because it takes away sort of important time for the brain, right, to work on the homework and so on. So is
that's a really great question. I don't have a very well-informed answer to your question, so let me not try to give an uninformed answer. I'll say a little bit of what I do know. There was related work in Boston that was really looking at the question of transportation and trying to move around scheduling and bus times. And part of the rationale there that was supported by the education literature is excuse me, how much sleep teenagers are getting, what time they wake up, and a lot of that is influenced by their commute times. There's a lot of literature showing that has a really strong effect on how well you can learn and retain learning. Yeah, so there's a lot of literature on this, not an expert. I'm sure there's a lot of evidence for not just distance being a nuisance, but actually having a causal effect on learning outcomes, but I don't know that literature. Good. And so how did the district arrive at these goals? That might be sort of a question that you also have. There's a long process of community engagement. There are a lot of things that were surfaced. Most of this was not driven by research. It was just like, what do people in the community want? And they were synthesized into these 3 goals. Yeah. Okay, great. And so that's where the district was when we started working with them. And the first thing that we wanted to do was, as I mentioned earlier, I've spent a lot of time thinking about these lottery systems. And so we wanted to help them think about, well, what are the potential policies? Maybe there's a broader space than what they've considered. And so we wanted to help them consider, first, what are the possible policies? And then second, can we give some prediction for how we think they'll perform? Okay. And so just as an introduction to my area of research, I work on something known as mechanism design. And at a high level, for those of you who haven't heard of mechanism design before, or your first time hearing about it was during yesterday's discussion session, a mechanism is just an algorithm. Okay? An algorithm is something that has an input and has an output. What makes it a mechanism is that the input is strategic. Okay? So the people who are putting the input in your system know something about how the algorithm works, and they're going to try to game what they put into the system to try to get the output that they like. Okay, so in the context of school choice, you can think that the algorithm is this lottery that tells you, based on which schools you say you like, where you get to go to school. And the strategic agents are families, right? If you really care where your kids are going to school, and you think that, oh, okay, I have a true first choice. It's this really popular school. I don't know if I have a very good chance. Okay, but maybe I can not say my true first choice. I think I don't have a good chance. I'm going to put my second choice, which is less popular. And if I put it first, maybe that's going to help my chances. And so there are a lot of natural algorithms that you might use for student assignment for which that does actually help you. Okay, and so what mechanism design asks is, how do we set up algorithms to achieve desirable strategic properties? Or how do we at least take into account the effect of how people are going to interact strategically when we look at the actual output that we expect and its properties? Okay, and so some of the desirable properties, it could be something like strategy proofness. So what strategy proofness is putting in your true preferences is going to give you a better outcome than putting in some not true preferences. Right? So there's no benefit to trying to game and being oh, my second choice is more beneficial. I'm going to put it ahead of my first choice. You might want your algorithm that you use to be strategy proof. And so in this literature, there are 2 commonly described mechanisms known as deferred acceptance, DA for short, and top trading cycles, TTC for short, that are strategy proof. Yeah, sorry, I really should have put the names. DA is deferred acceptance. This is known as the Gale-Shapley deferred acceptance algorithm. You might have heard of Gale-Shapley. Okay, and TTC is the Shapley scarf top trading cycles. Okay, and they have other properties that you might like. I'm not going to go into detail about them today, but a lot of this literature kind of comes up with economic properties like the one I just described. Another one is like measures of efficiency, how many people are getting what they want, can people do better? And you might ask which algorithms have these properties. And the nice thing about this school choice literature is a lot of these mechanisms, which were first devised sort of just as theoretical algorithms with theoretical properties, are actually used in practice. Okay, so deferred acceptance in particular, that first one is used in cities across the US, including in San Francisco, as well as other cities like New York City, Boston, Denver, DC. There's a bunch of papers in this literature describing their properties and also how they were used in these different cities. Okay, but going back to the districts problem, right? Not just how do we assign students to schools, but how do we try to get at these goals of proximity and diversity? Predictability is a little harder. We don't even know how to measure that. Okay, but for proximity and diversity, some of the ways that this literature has for trying to achieve those goals, the first is priorities. So let's say you want to have let people go to school close to home. What you can do in the algorithm is at each school, you can prioritize students who live close to the school. Okay, so other common priorities also include like sibling priority. In San Francisco, they also use something that they're now calling like an equity priority. It used to be called CTIP, which is the 20% of census tracts, which in the 2010 census had the lowest academic scores. Sort of historically, these are the educationally underserved. Let's give them top priority at all the schools. So lots of different kinds of priority to try to address things like historical inequity, proximity. And there's this broad sense that like for any objective you might have, even like diversity, you can set up priorities in such a way to achieve that goal. Yes?
Say in like a situation where you say give the priority to the students who've traditionally been in underserved schools, what then happens to like the low performing schools? Like who goes there and does anybody do anything to like improve those schools with resources or anything, or like what happens?
Great question. So today we're going to be focusing on student assignment, kind of keeping the schools fixed.
I guess like who gets assigned to those schools, I guess.
Yeah. So the first, just to clarify, the students who are given the priority are those who live in census tracts where the test scores of the students living in those census tracts in the past have been historically low. Okay, so it's not necessarily, they're not necessarily all going to the same school, although there are correlations. Yeah. So yeah, if we're moving people away from these low-performing schools, who goes into them? Really great question. A lot of the time, it's people who are designated, and so what you're pointing to is that sort of assignment alone is not going to completely address the issue. There have to be other things that are making these undesirable schools actually desirable. And so I could tell you lots of anecdotes that the city has about examples of this. Things that they do include, there's a new school that's just built or new facilities that can completely make a school that is very unpopular very popular. Other resources they can put in. They have sort of idiosyncratic examples of schools that were turned around and the different ways that were used to do this. But yeah, that's going to be outside the scope of assignment. But very important. Okay, but going back to how like student assignment thinks about how we might try to achieve distributional goals, the literature by and large is focused on using priorities. But if we're thinking about like analogs to zones, there's been a little bit of work on restricting choice and giving people like smaller menus of schools in an effort to get more predictability, like you have a smaller set to consider. And then the main tool that's usually used to try to get diversity is setting aside reserves at schools for students from certain groups. Okay? And so those reserves can be hard reserves. You have to be from that group to use the seat, or it could be soft reserves. You have priority at that seat. But if not enough people want to go to that school from that group, other groups can take the seats. Okay, so we just took this existing literature. Again, this is a very applied project. And we said, why don't we augment your space of possible policies? Okay, you wanted to use just zones. So why don't we, on top of zones, add all these other tools from the literature? So we added some priorities that we're trying to get at more diversity. To directly get at diversity, we also put in some reserves. I'm not going to tell you today about the reserves that we tried. This is just like a first hack. And then we also said, why don't we just try only priorities? And again, we set up these priorities to try to improve diversity. So this was all very heuristic. Okay. So okay, now step one. We've suggested a bunch of broad policies that they could consider based on the existing literature. Step two is, can we predict how we think these different policies will perform? What are the trade-offs between these different policies? And so to do that, well, first we have to instantiate the policies, right? So we're going to move to zones, like what zones should we use? And so this was a big part of the project then, and is a big ongoing part of the project now. And the approach we took then was, we said, well, let's take an optimization approach that's pretty standard for putting together neighborhood schools. And you've seen some of this described earlier in this workshop. Okay. And so what we're going to do is we're going to set up a math program to generate zones satisfying some constraints, which I'll show you in a moment. And then we did a two-step process, because unlike the neighborhood assignment, once you have zones, there are multiple schools in your zone, and we don't know which one you're going to end up assigned to. So on top of building the zones, we also have to look at, well, how are going to people choose between the schools in their zone? So we estimate a choice model and use that to determine the final assignment once we put that model into the deferred acceptance algorithm. Okay, so this is a two-step thing. The first step for the zones, the constraints are going to look something like this. I might have constraints on the shape. So you can have contiguous zones. That means every part of the zone, you can get to any part of the zone by staying in the zone. If it's non-contiguous, you could end up with islands, like this dark purple one has 3 little islands. Okay, I also have constraints on, I can set as a parameter the number of schools in the zone or the number of zones. And then there's all kinds of balance constraints. So the number of students across zones, the number of students with the number of seats in the zone, demographics in the zone, the performance of schools or popularity of schools across different zones. Yes?
So I'm just wondering, could have integrate the choice?
Yeah. So you're asking basically, why did we do this two-stage approach? All right, why not put it as one big optimization problem? Great question. The answer is that even this first stage is NP hard. And you can see these little blocks, attendance area blocks, that was the size of the geographic unit we were using to come up with these zones when we did this work initially. So right now, we're still working on how to approach this problem with much smaller building blocks, even just for the first stage. And even that is we're running into a lot of computation problems and trying to find all various heuristics to make it run faster. And so there are ways you can write big math programs that put them all together into one big one. We haven't yet figured out a way to make those tractable. I have a slide and 2 slides that goes into a little bit more detail about this. More thoughts, questions? Okay, so this is kind of the flavor of our approach. So now let me go into a little bit more just to make things more concrete. So this is what the optimization looks like. What we do, and I think you've seen examples of this before, is I have my building blocks, I have my zones, and the decision variable is, does a particular block belong in a particular zone? Okay, and so I'm not going to show you all the constraints, just some examples. So you might want some kind of diversity, and so that's the, take your favorite demographic measure, and ask if the proportion in each zone, so this is one particular zone Z, ask if that proportion is within some lower and upper bound. Contiguity is probably one of the more difficult constraints. So this is one way that we've tried enforcing contiguity. This is basically saying for every block, you look at its neighbors that are closer to the centroid of the zone than it is. And one of those neighbors needs to also be in the zone. And so this is quite sensitive to your definition of closer to, and is not sort of like a if and only if for contiguity. So there are lots of different ways that you can set up contiguity, and there's sort of a long existing literature on this. So that's a little taste of the first part. For the second part, we wanted to predict how people would choose if we change the policy. And so we looked at historical choice data. Something that's kind of difficult about our setting is that there are a lot of people who opt out. Okay, so in San Francisco, about 20% of students who apply to the San Francisco Public School District do not enroll in a San Francisco public school. Okay, so we have another paper kind of describing the effects of this and looking at some yield management ways of managing it. But that's just a reality for this part of the project. And so one thing we did was there is actually a lot of students who get their first choice and don't enroll. Okay, so there's about 5,000 incoming students. About 1,000 of them don't enroll, so that's our 20%. Of those, 400 received their first choice. Okay, so these are people who are probably they're entering because school year, the application season is in December and January. They don't know then whether they have a private school option. As soon as they get their private school option, off they are to private school, and they don't come back. Okay. And so we have to estimate quite a lot of things. The standard approach is just to estimate how much do students like each school. This is their standard random utility choice modeling. For this work, we just did the standard multinomial logit choice model, but we've been doing follow-up work to kind of be a bit more careful about the specifics of the setting. But then we also need to look at, will students list a school? Right? Because there's like 150 programs, 70 schools. You're only going to list some small number of them, and we see really big differences between race, socioeconomic status for how many schools people are listing. And if you're listing fewer schools, well, that's going to change how you get assigned. And then finally, after we list the school, will they attend the school? And so we're always continually, this one is always continually in progress, because my belief is we just don't have like good enough data to be able to predict who's going to stay or leave. But we do the best that we can. Okay. And so we have this whole sort of pipeline. We're predicting preferences. We're helping design the policies. We have computation for zones. And we also set up some dashboards for people to be able to look at visually what these zones look like and how they're performing. Okay. And so just to say a little bit more on, well, what are some of the mathematical questions for how to create zones? There's a lot of existing literature this looks kind of like, right? It looks kind of like school districting for just neighborhood schools. But one of the issues is that there are multiple schools per district. And so the usual approach is you take your school and you let it be the centroid of that zone. But now you get to decide on the set of schools. Like, so how do you where is the centroid that you start from when you're coming up with the zones? It also feels similar to like a small scale political redistricting problem, right? It's quite small, which is nice. What's not nice is that there are it's much more constrained, right? And so this constraint actually means that a lot of the approaches, sampling-based approaches in political redistricting, are kind of getting stuck locally very fast in our highly constrained space. And so that's something that also turns up in political redistricting. And so we're kind of looking at, well, how can we adapt those approaches for our type of problem?
So in your designing the zones, you mentioned contiguity constraints. Do you also consider the compactness?
Yes, we also look at compactness. Yeah, and again, lots of different ways you can try to put things in your objective or constraint to get compactness, which is zones that look nice and circular rather than like snaky with tendrils. Okay. Then we're also doing some things about choice. In particular, I think that the novel thing here is we're not really trying to predict exactly what you choose. We want to have a good prediction of the outcomes after choice, and we've done all the assignment. And those are different things. So one really clear example of that is Right now, because of the way that we set up the choice model, a lot of it is random. And so if we put that together with our best prediction for how long your list is, we're actually not getting like really good predictions of like your entire list, right? Because there's a lot of correlation between the schools on your list and what kind of schools you've listed before you like stop listing schools. Right? So we could be doing really well on predicting each of those individually, but then when we put them together in this way and look at the outcomes, we're doing a really bad job of predicting outcomes. Yes.
So sometimes when options in the choice set are too similar to each other, you have just convergence problems because you just can't discern what's different about them. So there are some methods to like sample undesirable options or like to take the whole set of potential schools, even though they're very far away and undesirable, because then at least you can kind of see why you chose the things you chose. So there might be some methods to make it converge better.
Yeah. I'd love to talk about this offline. I think there are a lot of really interesting questions about how we can be cleverer about predicting choice, and that sounds fascinating. Thank you. Okay. So the question that was raised earlier, can we put it all together into one big optimization problem? There are also a bunch of other questions. I'm not going to explain this one since I'm a little bit low on time, but lots of interesting things in this space that are, I think, primarily mathematical questions. Okay, so here are our results. And then, oh gosh, I guess I'll need to go quickly to have any time to discuss. Okay, but the results I'm showing you are based on historical data. We have preferences from 2013 for this paper through 2020. Now we have it through this year, 2023, and enrollment the following year. And the simulations I'm showing you here, I'm using applicants to kindergarten for 2018-19. What I'm going to show you is the choice model that we estimated. And this was estimated using 5 years of historical choice data. And I'm going to show you averages over 100 realizations of all the randomness. There's randomness in the utility model. There's randomness in the assignment itself. Okay. So here are the policies I'm going to compare. These two left-hand policies are sort of like a benchmark based on this Boston personalized menu. HB stands for home-based, which is what they called it in Boston. These three are the three that I described to you before, just using the zones, one set of medium zones, which I think I have a picture of them coming up in a second, zones with the reserves, and then just using diversity priorities. And then we're comparing all of that to the actual assignment in 2018-19. In the paper, we also have a couple of other ones, including like a simulated actual using all of our choice, using the way they were doing the assignment process, but going through all of the choice modeling and averaging. Okay, let me walk you through some of these. First, let's look at diversity. So what I'm measuring here, we have a lot of metrics in the paper, but here I'm just showing you one representative one. This is percentage of racial minorities. In San Francisco, they define that to be African American, Latinx, and Pacific Islander students. In schools with this number here, this is 15% more than the district average of students eligible for free reduced price lunch. Okay, so you can think of this as like mid to high poverty schools. There's really concentration of socioeconomic need. So what percentage of my racial minorities are assigned to these schools? In the actual assignment, it was about 30%. By moving to either zones and reserves or priorities, we could more than halve that, right, to 11 or 13%. Looking at proximity, all of these kind of restrict the set of schools that you apply to or are eligible for to like a pretty small, closer set. And so, of course, most measures of proximity are improving. Okay, this is just average bird's eye distance in miles. This is a transportation workshop. I have a whole slide later on discussing what are more clever things we could do here. Okay. It's good to note that these priorities we'd set up very heuristically just for diversity are not helping with proximity, but we could set up other priorities that help with proximity. And that's something that you could kind of combine distance-based priorities to reserves that are trying to get at diversity. And so I don't have that benchmark for you here, but that's something that we're putting together. Okay. Choice. Okay. A lot of these policies restrict the set of schools that you get to go to. And so they all reduce the amount of choice that people get. And so here we're looking at the percentage of students assigned to one of their top 3 choices, and this is top 3 throughout the whole district, right? Including those that you're no longer eligible to apply to. Okay, and that's obviously going to go down, but what's interesting is how much it goes down. Yeah, you can see from about 80% of students getting one of their top 3 choices to like 60% in zones and reserves. That's a big reduction. And so you might worry that families will not be happy. Right? In particular, some families who really might not be happy are those who are designated. Okay, so those are students who are not assigned to one of their options. And so when we did this work, one cautionary thing we did was we said, let's just remove everyone who is designated, put in a school that they did not pick. Then this beautiful number of 11% is going to go all the way to 40% of racial minorities in mid to high poverty schools. Okay? So going back to the earlier question, like who gets assigned to these schools and will they stay? Right? We were basically saying like reassigning students alone is not going to solve this issue, right? Like having a diverse set of students assigned to the schools doesn't mean that they'll all go, and it doesn't mean they're integrated and really getting the benefits of being in a diverse school. So student assignment cannot work alone. Okay. Despite this, the board looked at our trade-offs table, looked a little bit like this, and they were like, oh, this is a great policy. It achieves all of our goals. We like this one. Let's do zones and reserves. Okay, so, oh, I had some slides on it. After. So we showed them a lot of things like this, not just this one number. We had lots of plots. They're all available publicly on the, because all the board meetings are public. Okay. I had some stuff also on equity. I'm just going to skip over that. But, okay, so they said, let's restrict choice using geographic zones and reserves. And also they wanted to add something. They wanted to keep these equity priorities, but update them. Okay. And so, well, the first thing that we said is, okay, like let's be like serious about the negative effects of reducing choice. And this 40% that I showed you, let's see like how many people do we think will actually leave as a result of having less choice? How much should the district really invest in like making sure people are happy with their schools? Interestingly, we see that your assigned school doesn't have like a huge effect on whether you stay or you leave. Like the most predictive things are just your zip code, income, and race. And so some of the things we've been working on are benchmarks, actually selecting the specific zones, priorities, and reserves, and not using these hacks that we did to put together the high-level trade-off table. And this is the one I wanted to discuss with you guys. Like, what are some of like the transportation questions that we might have? There's other things we're working on. Like right now, they're thinking about maybe we can move some programs around, the facility location kind of problem. Eventually, we also want to look at the effects on, well, where are people going to move if we have this new geographically based assignment policy? Okay. So on equity, I'm just going to make 2 points. The first is that if we want to like start thinking about how do we define equity of access in student assignment systems. The Glossary of Education Reform defines equity as the ways in which educational institutions and policies strive to ensure the removal of any barriers that might prevent some students from equitable participation in certain courses or academic programs. And so if I slightly rejiggle this, the ways in which, for us, student assignment strives to ensure the removal of any barriers that might prevent some students from equitable enrollment in programs serving their unique needs. Okay? And so if I take this statement seriously and look at the whole student assignment process, it actually looks something like this, from when you're submitting your preferences in December or January, well, forming your preferences, submitting them, where you're assigned, and then can you like get there? Right? And so if we had more time, I would have shown you a bunch of things about the assignment. But if we're really serious about equity, we want to think about, well, what information do people have about schools? How much do they understand this whole like mechanism, algorithm, black box thing I like hand waved at you? And can they actually get to schools? And then above all of this, there's also this element of procedural justice, which is how much do people trust in like this whole process, how the policy was decided, how it's run every year, and believe that it's for them. And I think these are all things to consider if we want to be serious about equitable access, just in the problem of student assignment. And so I had some things that I wanted to share with you on all of these, but I'm just going to go to the transportation one. Okay, and here I have, some of the other ones we have some work. I have no work here. I don't work on transportation, and so this is an invitation. If any of these are interesting to you, come talk to me. First question would be at a basic level, how do we measure transportation access? How do we see who has a real option to get to that school versus not? And so we've tried a bunch of things and what I showed you, I was just doing bird's eye distance. We've also looked at driving time, but with driving time, there's this issue that Google Maps thinks everything is just 30 minutes drive. That's not true, especially in rush hour. Okay. We've also looked at, not just average distance, but not too close, a good level of close. So can you walk to school? Is it too far? Can you access via public transit? Sort of being very specific about what that is. A big question in San Francisco that we would like to answer. So they don't really have budget for school busing beyond for students with special needs. But one thing we're interested in is, how much would budget help? Right? If we were at X amount of budget, how much more equitable, how many more students would have access to different schools? So there's a lot of things you have to do to answer that question, right? Where do you put the bus routes? How will that change choice, right? Because now we have, if there's a school that you can get to that you couldn't get to before, right? There's a lot of equilibrium effects. And some other equilibrium effects are, now if people start going to other schools, maybe that will change where we should put the bus routes. Depending on where the bus routes are, that might depend how people are driving to school. It might just change rush hour traffic patterns. Yeah. So there's a lot of things that multi-stage kind of modeling that needs to be done. Okay. So I also had some points about procedural justice. I'm just going to challenge us all to at least consider, this quote, "It's always families and communities with fewer resources that get stuck with lower quality schools and choice." Okay, and so this was something that came out of 2021 fall engagement. They were asking, which policy concept do you like? And the Black and Latinx families said none of them. Okay, so that's something also to consider. Okay, so with that, let me close with some thanks to my collaborators for the main paper that I presented today, as well as collaborators with other projects that I had slides for but didn't talk about, and the many people who we're currently working with on this project. Thank you.